Okay. So we are heading to a thing called, and you can just watch for a minute. We're gonna fake some of the front because I don't want to take as much time as I had planned. I want this lesson to go a little faster. We're doing a thing called the line of best fit. So I love this stuff because it's finally real, right? Remember what I told you the whole time, that math is about being able to make predictions, right? So yeah, the baby animals was nice and clean. The data came out, it was perfect, it worked the same way every time. But in real life, data is not always that clean. If we're looking even at COVID data, if you have talked to anyone, some people get, if you've gotten COVID, some people are like, oh yeah, I got it and I tested negative 5 days later. And then Thomas got COVID twice, and like on the third day, he tested negative when he got it the second time. Caroline tested negative like on the sixth day, and for me, it took me 11 days till I finally tested negative, right? Because it just depends. So what we do in the world is we try to see if there's patterns, right? And sometimes the patterns are perfect and lovely, and sometimes the patterns are not so perfect. But we want to use the data the best that we can to make predictions, right? The reality is some people, it took 12 or 13 days to test negative. Some people did it really fast. So what scientists did is they said, hey, 10 is a pretty good estimate. I mean, that's really how we make decisions. And what we do is we take real life data, we graph it, we see, I think if there is a pattern, we make an equation for that pattern, and we use that data. That's how real science works, and it's called line of best fit. And we're going to use pretty simple lines. So the first thing I want you to do, I'm not going to have you actually graph this data. You could, it would really work, but I don't want to take as much time. So what would happen maybe is if you graph this data, and again, if you go back later and be like, where did you get those dots from? I'm just making it up so I can do it pretty quickly, right? So if you graph this data, it might look like this, right? And if you looked at it, you would say, hey, I actually see a pattern, right? I can kind of see a pattern happening here. Do you see how it's kind of going like this, right? The data's going like that. That's called a correlation. And you might want to write that word down. Anytime you can see a pattern, it's called a correlation, right? A correlation. Sometimes there are negative correlations, meaning if something starts up here and it goes down and you get less and less of it, that would be a negative correlation, right? Sometimes you're going to get data that might look like this. This is the next one, and if you graphed it, it would look something like this. And this would be a positive correlation, right? Because it's going up. Does that make sense? Now, here's what's interesting. Sometimes there are things with very strong correlations, meaning the data is clumped really nicely. Do you see on this guy? Take a look at this. Do you see how it's almost in a straight line, right? It's really nice. But if you look at this guy, do you see how it's kind of all over the place? And sometimes you might even get like a random one that's like way over here. So sometimes the correlation is strong. That means the data is clumped together in a nice pattern. Sometimes the correlation is weak. And when it's weak, it's kind of a little bit like spread out. It's a little fatter. And sometimes your data looks like this. And you know what? Sometimes there's no correlation. It has nothing to do with each other. Like, I'll be honest, if you gave me your shoe size and your IQ, they have nothing to do with each other. You're going to get people with very big feet who are very smart, and you're going to get people with very big feet who are not very smart, right? Because they don't really have anything to do with each other. You can't really predict by someone's shoe size how smart they are. But you know what you can predict? You can predict how, by someone's shoe size, how tall they are. It's not perfect. You can have some short people like me with really big feet, and you can have some really tall people with teeny tiny feet, but it's rare. It's kind of the bigger you are, the taller you are, the bigger your feet are going to be, right? Because that's got a correlative value, right? So what we're going to be doing is this. We're going to be taking data that maybe looks like this, and we're going to be trying to make a line that fits the data. Now, here's what's interesting about that. Let's see if I can make, let's see, I'm going to go back. Let's go back to here. So I am going to get rid of, give me just a second here. I'm going to get rid of some of this stuff. I've just taken away the blue part. I'm just putting some random dots on here. Now, oh, that's not what I wanted. I'm going here. So I got some random dots here. There they are. Okay. So here's what I want to do. I want to make a line that fits this data. But here's why this is weird. Your line and my line may be different, and that's okay. But what we want them to be is a line that at least is, it's called the line of best fit. Meaning it might not be perfect, but it's going to be pretty damn good. So watch this. If I drew a line, oh, let me give you one more dot. I'm going to make one more random dot right here, right? Watch if I drew a line from here to here. Why does that keep doing that? Okay, let's see if I can make it come back. I'm going to go from here. There's a dot right here. I'm going to go from here to here. Okay, I'm not going to touch anything. I feel like I keep touching it. Does that line represent that data very well? Is that line right in the middle of all of the data? No, it's not. Look, all the data's up here, and that weird-ass line is down there. What I want to do is I want to draw a line that's right in the middle of my data. That really is like there's some of it above it, there's some of it below it, but it really totally is right in the middle. So maybe a better line might go from here to say here. Do you see that's better? I got some up here and some down here. I could even do a line, say, that goes like this. Look at that bad boy. He's got a little bit on the top. He's got a little bit on the bottom. I get to decide. It's up to me, right? Your line might be slightly different than my line, and that's okay, because as long as you've done it correctly, you're going to get a line that pretty much represents that data. So then what we're going to do is we're going to take 2 points on our line. They might not even be any of these points. I might use this guy right here and say, oh, I don't know, this guy right here, and think those are 2 good points. I'm going to write the equation of the line using the points that best represent my line. Does that make sense to everyone? Yeah? And then what I'm going to do is with that, I'm going to make some guesses. Like, for example, if this was shoe size and height, I might say, okay, well, then what if I have a size 7 shoe? What height could I guess it to be, right? So once we have our line, we can make predictions. So one thing I do want you to write on the little thing that there's a little space on your front part, there's a little blank. I want you to write the word interpolation and extrapolation. We are going to make today and tomorrow, we have a good activity you'll like tomorrow. We're going to make predictions. Oops, why did I put that S down there? That was weird. Of predictions with our lines. And there's 2 types of predictions that we can make. We can make predictions that fall within our data set. So let's think about this, the example I gave about, and we're going to actually maybe do this one in class right now, shoe size to height, right? So if I want to guess, and I'm going to say, okay, I asked different people, and you gave me different shoe sizes, like you're a size 5, and you're a size 10, and you're a size 12, and I'm going to say, okay, I want to make a guess about how tall someone with an 11 shoe is. That is called interpolation. That is a guess.
Here's what I found.
Stop. Using data within our data set, right? Now, here's what's weird. Imagine I wanted to know how tall someone is if they have teeny tiny feet, right? Like baby's feet. Like if you took a baby. Well, babies are weird, right? Their feet size don't really do with their height, right? It's like babies are like that. It's like you don't have babies with big feet and babies with little feet. Babies just all have little feet. So if I ask you about baby feet, that is outside of our data set. If I just am asking you guys about your feet, and then I ask about baby feet aren't going to work very well. That is trying to make a guess using data outside of our data set. Now, sometimes it will work. But you know what? Extrapolation, not as dependable. Interpolation, we can depend. But extrapolation, we can't depend on that. It's kind of sketchy. Once you start going outside, it starts getting sketchy. So when we're going to be making guesses, and we're going to be using numbers that are inside of our data set, that's called interpolation, and those are pretty good guesses. They're pretty good. If we're going to be making guesses, so for example, if I said someone had a size, I don't know, like 20 foot, that would mean they're like 15 feet tall. And that doesn't make any sense, right? So once we go outside of our data set, it gets a little sketchy. Does that make sense? Okay, so enough talk. Let's do it. We're going to do one. So here we are. Turn your papers over. You're going to see it so much better. So this is some data about people who've decided to take a test, right? And they've studied for the test, and they want to see if there is a relationship between how long you've studied and what your grade is. So what we're going to do when we do lines of best fit, the first thing we do, graph our data. That's our first thing. So let's talk about making a graph here. So at the bottom, we're going to use the number of hours. That's our hours, right? So we want to label our graph. That's hours. Now look, we don't want to go 1 to 100. No one studied for 100 hours. It looks like if I go like 1 to 5, no one really did more than 5, I should be okay, right? Now, if you want, you can make your graph kind of tiny and make it 1, 2, 3, 4, 5, but I'm going to spread it out a little bit because it makes it look nice. So here's what I'm going to do, and you can do what kind of works best for you. I'm going to go 0 right here. I'm going to go 1 hour right there, 2 hours right there, 3 hours right there, 4 hours right there, and 5 hours right there. Is everybody cool with that? Right, those are my hours. On the y-axis, that's going to be grades, and we're going to make certain that we label our graph because we're going to be doing it. Now, this one's going to be a little bit trickier because I need to get all the way up. The highest grade on there was a 92, so I need to get all the way up to 92. So I clearly do not want to go 1, 2, 3, 4, 5, 6, 7, 8 because I don't have that much paper, right? I don't want to do that. So we're going to use a couple of tricks. Trick number 1 is this. If you have a bunch of space on your graph that's not being used, there's a trick that we can use, and that's going to be called condensing our graph. So check this out. The lowest graph we get is a 63. So do I need 50s or 40s or 30s on my graph? I don't, right? So what I'm going to do, I start at 0. I'm going to make a weird little symbol down here. Watch what I'm going to do. I'm going to go like this. Do you know what that means? It means what I've done is I've squished my graph down to ignore the data I didn't use, right? So I'm going to start my graph maybe right here at 60, right? Because that's probably the lowest I need to go. 50, 49, 38, all the rest of it, it's there. I just squished it down so we didn't see it. So if you don't want to go ahead and go 0 to 100, which you don't want to, you can use that little trick. Is that cool? So now what you need to do on your graph, you need to go up. But guess what? We need to go up by equal amounts, right? You just can't put these random numbers in here. So I need to go from 60 all the way, it looks like, to 92. So you can go by 2s maybe on your graph, or you can go by 5s if you want, or you can go by 3s. You could go by 1s if you want, but that's a lot of graph paper, right? So go ahead right now with your table mates. Decide what, like what scale you want to do it at. It's up to you. You get to pick. I think I'm going to go by 2s. 62, 64. I would have done 3s, but I just can't count by 3s very well because I'm kind of stupid. 6, 78, 80. I'm getting close. 82, 84, 86, 88, 90, and then there will be my 92. I think I'm good. Everybody okay with that? And now what you're going to do is you're going to take 3 minutes with each other. You're going to graph your data. Put your data on there. Let's see if there's a pattern. If you studied more, did you do better? Let's see. Go ahead and put it on there. I'm going to do it while you're doing it, so we have it all done together. That's 63 right there. 1 hour, I got 70 there. 2 hours, I got 77. The other 2 hours, I got 75. Right there. 4 hours, I got 90. Way up here. Yay for him. 5 hours. Ooh, 3, I got 84. If anyone is watching this at home, they're just hearing me talk to myself. 5 hours, I got 92. Nice. How does yours look? Does yours look good? Does yours look something like that? Yeah? Okay. So, there is a correlation. There's a pretty good correlation. It does seem that the more you studied, the better you do, right? So, we're going to now see if we can write an equation to model this situation. You guys ready? So here's what you might want to do. I'm sorry that I don't have this. I am going to pass out some graph paper. 1, you might want to use it later. And 2 is if you fold it in half, it will give you a straight edge. We need to draw a line in there, and we need it to be a nice straight line, right? So we need it to be a nice straight line. So if you just kind of fold it, that folds. Now here's where this is going to get weird. Your answer to this next problem and mine may be completely different, but as long as they're in the ballpark, we should be fine. Okay. So here's where this gets weird. I need to put a line on here. I get to decide where the line goes, right? So what some kids automatically do is they take the lowest point and the highest point and they connect them. Well, I'm going to show you something real quick. What if your highest point, now this didn't really happen, but what if your highest point was really right over here, right? And I went ahead and I connected this point to this point. Would that be a good line of best fit? No, I'm not even close to being in the middle of the data, right? So what I want to make sure I do, and let me get rid of that other weird point, is I'm going to put a line that I like right in the middle of that data, right? Some people like connecting 2 points. That's awesome. Some people like using their own 2 points. That is cool too. So right now, I would like you to use your straight edge and put a line where you think it goes in the middle of this data. I am going to do it my own self, and I will show you kind of where I want it to go. Now I'm going to go, oh, that was not what I wanted it to happen. Let's see if I can make this work. La la la. I want it to be really little. Okay. Still not going to happen. Okay. So I think my line would go somewhere like this. Ooh, I tried to make it a nice line like this. Ooh, that's not great. That's not great. Maybe I would do it more like this. See if I can move it over a little bit. Will you move? Oh my God, I love this board so much. Like maybe like that? Does that look okay? Yeah? Does that look pretty much in the middle? So now what I'm going to do is I'm going to look at that and I'm going to find 2 points on that line. 2 good points. They can either be data points, but they don't have to be. So I'm going to show you the ones that I'm going to use. I like this point, say, right here. That looks like a good point. And look at that point right there. Those are 2 nice points. And then I'm going to do everything I did on the starter with those points. Does that make sense? Your points may be different than mine, but as long as you did the right thing, our answers will be similar, right? So when I go to grade your tests, I know what a good range for my slope is. I know what a good range for my B is. So what I'd like you to do, and this is tricky with your neighbors, see if you can together, write an equation for your points. I'm going to tell you right now, I am going to be using point. It looks like, oh, yuck, I don't like that point anymore. It's 1.5. Ew, yuck. I'm picking a new point. Sorry, 1.5. I hate you. I want to do, is that another half? Ooh, that's a better point. I'm going to use that one instead. And is that another? Oh, that's better. That's better. I like this one. I'm going to use that guy and that guy. And you're allowed to fix it. Like if you don't like the point you pick different ones. As long as they're on your line, right? So I think what I'm going to do is use this guy, which looks like he is 3, 82. 3, 82. And I'm going to use this guy, which looks like he is 4, 88. Ooh, I like those. 4, 88. Does that make sense? Okay, I'm going to walk around and see how you're doing. I'm going to show you what slope I get, and your slope should be close to my slope. It should be in the ballpark. Might not be exact. Okay, so make sure though when you are looking to use the points, like you use good glasses. Does that make sense? Yeah. Everybody okay? Yeah? Nice. Your line looks great. Okay, so here's what I'm going to say. I'm going to change. So I'm going to get 6 over 1. So did you guys get an M that is somewhere in the neighborhood of 6? Like something like that? Yeah, somewhere in the neighborhood. Can I see if you got a slope that's somewhere in the neighborhood between 5 and 7? Can you raise your hand if you got a slope between 5 and 7? Awesome. That's what I'm looking for. That would be correct, right? That would be correct. So now let's go ahead and plug in to get our B. You guys ready? So here we go. I am going to erase. Okay, so I'm using this guy, and I'm going to say y equals 6x plus b. I'm going to go back. I'm going to use that, was it 3 and 82? I'm going to say 82 right here. 6 times 3 plus b. 82 equals 18 plus b. B equals, I'm going to do it on my calculator because I don't like subtracting by 82 because I'm a baby and I could do it in my head if I thought about it, but I'm too lazy. So 82 take away 18, I got 64. Okay, so here is my equation. So here's what I want to know. You would get this right if You got a slope between 5 and 7, and you got a B between 50 and 70. Can you raise your hand if you graph a good line? Awesome, awesome. That's how you do this. Now what I can do is I can say, okay, so let's go one more step. I'm going to say, so you decide that you have 4.5 hours to study. Plug in 4.5 and tell me what grade you can expect to get on your test. What grade should you get if you study for 4.5? 4.5 hours. We're plugging that in for X. Does that make sense? We're interpolating because 4 fits in our data. It fits in our data. It's tricky. This stuff is tricky. So for me, if I did it using my thing, I'm going to say 6 times 4.5 plus 64. I should get a low A. How many people think they'll, if they did 4.5, their thing says they should get a low A or a high B? 90. So did I. Yeah. So that's how I grade this. I look at it and say, does your answer make sense? If you told me you should get 130, then that means something was off on your graph. If you told me you should study 4.5 hours and you get a 71, that means something's off in your graph. Does that make sense? Okay, we're going to try one more of these and then we're going to be quiet, and you have one problem for homework. So we're going to actually try the height and the shoe size. Do you guys know how to do your height in inches? Right? So 60 is 5 feet, and then just add on, big babies. I just want to ask some random people. So I'm going to look for someone tall. How tall are you, babe? So that would be 60, let's see, 65? No, 75 inches? So 60 is 5 foot. So you're going to add 12 and then 3 more. So 6, is that right? So you are 75. Oops, let me get rid of that. You are 75. And what size shoe do you have? Ooh, interesting. I like that. Okay, let's try, let's go to someone smaller. Can I ask? How tall are you?
I am 62 inches.
Nice, 62. And what size shoe do you wear?
I wear a women's 7.
A women's 7. So to get to men's, we would take a 1.5 away. So that would be a 5.5 for men. You with me? Okay. And let's go with, let's see, someone. Will, how tall are you?
67 inches.
67. Can I, oh, nice in the middle. I appreciate that. What size shoe?
9.5.
Okay. Let's go 9.5. Let's find a couple more. Alex, how tall are you? So do you?
67.
67 again. And what size shoe?
8.5 in women's.
So it would be a 7 in men's, right? And let's do one more. Max, let's go with you. How tall are you?
72.
Nice. And what size shoe?
13.
Nice, interesting. Okay, can you do me a favor? Can you graph that? So can you go ahead and graph it? And let's see if we have a correlation. So here's a couple things you might want to do. On the bottom one, you might want to go by halves, right? Start at 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13. Yes. Oh, so this will be our, you know what I would do? Let's do this. I think it might be easiest if we make, it doesn't really matter. You guys want to do this is our X and this is our Y? You guys want that? You want feet, shoes are on the bottom? Yeah? Yeah. I'll do that in my other class. I'll flip those. I don't know why. We like the lower numbers on the bottom, huh? But you could do it the other way and it will still work. So I'm going to go 5. I'm going to start at 0. Start at 0. And remember, I'm doing that little squiggly thing, right? Because I'm not going up one at a time. So I'm going to start at 0, do the little squiggly thing, do the little squiggly thing, 5, 5.5. You don't even have to do the halves. You can just go 5, 6, 7 and put your dots in the middle if you want. It's up to you.
Oh, I.
Yeah, that's perfect.
Okay.
Yeah, that's totally fine. Again, it's your call, right? So I think I'm gonna do that. I'm gonna just go 5, 6, 7, 8, 9, 10, 11, 12, 13. And then that's my squiggly. And then my squiggly right there, I'm going to start, like at 60, 60, 62, 64, 66, 68, 70, 72, 74, oops, 76. Is that as big as we got? Yeah, that should be good. So here I go. I'm going to start 13 to 75. 13 to 75 right here. Boom. I'm going to go 5.5 to 62. So 5.5 is up here at 62. Ooh, it's right there. How cute is that? And then I'm going to go 67. And I'm going to go 9.5 way over here. I think I forgot a number. That's not good. No, 7, 8, 9, there it is. 9.5 was at 67. Right there. And another 60, way down here at size 7 is 9.5, 67, right there. And 72, 13. 13, 72. Okay, so there is a correlation. It's not super strong, but it's there. So here's where I'm going to put my line of best fit. I think, to be honest, I might use this point like right here and maybe this point right there because that looks like a pretty good line of fit. Does that make sense? Yeah?
Does it matter which way you put your line at?
Or you put your axes on the other axis?
Yeah.
Perfect. It works totally perfectly. Your equation will turn out different, but when you plug in, it would work out fine. So I'm stopping here because now you guys got the hang of it. That's what we're going to do tonight, right? We're going to graph our data. We're going to connect it up. We're going to write a line of best fit. And I think because I chatted, this took a while. Bye, COVID kids.